Hi, I'm Scott Coleman, Director of Project Management here at Owl Cyber Defense. In previous Owl Advantage series, we talked about data diodes themselves, the physical components and their theory of operation, how they move data from a protected enclave to the big bad internet out there, and how it's done securely without anybody coming back. So if we look a little bit deeper into the actual design and the software that runs on top of the physical hardware, we can understand how we can achieve high reliability, low latency, and high bandwidth out of these devices. So the first thing that happens is traffic comes in to our source side. That traffic is coming in the form of a TCP/IP packet or a UDP packet or a file transfer, something along those lines. Traffic is terminated here. At this point, we're going to take the packets, we're actually going to break them apart. We break it apart so that we only use the payload. We don't include the header information about the packet itself. Payload is then moved onto what we use as ATM. This is an asynchronous transfer mode protocol developed by the phone companies, removing high bandwidth voice and data. So we're sticking our payload packets into an ATM cell, traveling across to the other side. At the other side, we have a table that receives that information, identifies where that payload needs to go, puts it back into, let's say it came across as TCP/IP, puts it back into a TCP/IP session and sends it on its way. A couple of things that are happening here. One, we've got the proxy that's terminating those sessions. Number two, we're moving the payload only. Number three, we're using ATM as our transport. Again, high reliability, low latency, so we're moving a lot of traffic across very reliably to get to the other side. And then three, none of the routable information comes across. So no IP addresses, no MAC addresses, none of that header information that actually identifies. We've got a non-routable protocol break in the middle. We're going from, in this case, TCP/IP to ATM back to TCP/IP. So any vulnerabilities that could be hidden in that traffic would be completely stripped out and only the payload moves across. So it's a combination of these things that get us to those kind of key things. Is how can we move traffic so much faster than competitive products? Well, it's the core of what we do. It's the components, the hardware components themselves, and it's how we design the software to manage the packet flow across the diode from point A to point B.